Hey everyone, we're going to go through some notes. So everything that's written on the paper here, please get down. Feel free to pause or rewind this video at any moment if you need to get caught up. Okay, so today we're going to be talking about percents and expressions. And today is 3/8. Okay, so for today's lesson, we're going to be thinking about what we've learned earlier this year with percents, and we're going to apply that to expressions, obviously, right? So we're going to do two practice problems right off the bat. A shirt is 35% off. What is the new price? Earlier in the year, we've dealt with these problems where the original price is given. And let's say that that original price is $20. So we're trying to figure out what is 35% of 20. That's going to be the markdown price. And then we're going to subtract that from 20. Let me show you what I mean. So we're going to go back to our equation. Part equals whole times percent as a decimal. We're trying to figure out what is 35% of 20. So we're looking for the part. The whole is the original price, 20. And my percent as a decimal is 0.35. Remember, I'm just moving the decimal over 2 times to get it into decimal form. Plug this into your calculator, and we get part equals 7. So 20 times 0.35 is 7. So that's how much the discount is, but to find the new price, we need to do original minus discount equals new price. Well, the original is $20. We're taking $7 off. So that equals 20 minus 7 is 13. There's our answer. Well, a shirt that's originally $20 and 35% off, the new sales price is $13. That should be very familiar to you guys. This is what we were doing earlier in the year. But what if I were to say to you that we don't know the price of the shirt? Well, we've been dealing with this idea of variables, so we're going to apply that idea to today's lesson. So if the original price of the shirt is X, we don't know what it is. It could be anything. But we're going to set up an expression that demonstrates what a shirt would be at 35% off. And we're going to do it in the same way that we did here. Let me show you what I mean. We're going to say part equals whole times percent as a decimal, just like what we did over here. We're looking for the part, so that's what we're solving for. And I'm using the question mark because X is, we're already going to use that on the other side. What's the whole going to be? What are we going to put in place for the whole? Well, over here, we put 20 in because that was the original price. The original price here is going to be X, so I'm going to leave that as X. It could be anything. It could be $5, it could be $20, it could be $100. And then my percent as a decimal would be the same, 0.35. Okay, so I can rewrite this. The part that's being discounted is going to be 0.35 times X. I just flipped these two around. We're used to seeing the coefficient in the front. Okay, so This is going to be the discount. In the same way that the part was our discount over here. So whatever the price of our shirt is, we're going to take this away. This will make a little bit more sense when I do my original minus discount equals new price. So my original, remember, is X. So I'm going to plug that in. X minus how much are we getting a discount for? How much are we taking away in the sale? Well, we just figured it out here in terms of X. That's 0.35 X. And that's going to give us our new price. Now, can I simplify this at all? Yes, I can. They're both the variable X. And all we need to do is combine, really combine our coefficients. What's our coefficient here? There's none written. Well, we know that there's always a 1 written there. So all I need to do is 1 minus 0.35 to get my new coefficient, which is 0.65x. So this expression is the shirt that's 35% off at whatever new price it is. If the shirt was $5, we could plug this in and figure out what the new price of the shirt is after the discount. If it was $10, if it was $20, so on and so on, we could plug it in, and it's always going to be 0.65 times the original price. So you'll notice the connection, 0.65 and 0.35 adds up to 100, or 1 in this case. So we can use that expression with the 35% to figure out what the price of a shirt would be if it's unknown at the time. Okay, so that's going to be our expression for a shirt that is 35% off. And we followed all of these steps here. Let's do another one. A new box of pasta claims that it contains 25% more pasta than the usual box. Create an expression that represents the amount of pasta P in the new box. Okay, so our variable here is going to be P, which represents the amount of pasta. So we've got an original box. This new box comes out. It says it's going to be 25% more. What is an expression that represents that new box that's got more pasta in it? Okay, so here's how this one's going to look in terms of an expression. We've got the original amount. We're going to add a 25% increase. And that's going to give us the amount in the new box. Okay, so the original amount is just going to be P, what we're starting off with. The amount of pasta is just going to be P for the original. And this 25% increase, well, we got to figure that out. And we're going to use our friend part times whole equals percent as a decimal. We're looking for the part, so we're going to fill in the whole, which in this case is P. P is the original amount, so whole and the original amount are usually the same. And our percent as a decimal is 0.25. Yeah. And again, we're going to be adding these two. So I got my original amount P, my 25% increase, which is just going to be 0.25 P. And I'm going to now, that's going to leave me with P plus 0.25 P. This is going to be the amount that's going to be increased. Sorry, this is the amount, the new amount in the box. Can we combine like terms? Yes, we can. There's always a 1 in here. Let's combine coefficients. 1 and 0.25 equals 1.25. My variable comes along for the ride, and that is my answer. This is the expression that represents the amount in the new box after it's been increased by 25%. So the way I think of this is 1, right? That's our starting point, 1P. We're increasing it by 25% or 0.25. We combine the 1 and the 0.25 together, and the P goes along for the ride. So whatever amount that we started with in the box of pasta, we're going to multiply that by 1.25, and that's going to give us a 25% increase. And that's all I got. Thanks for paying attention. Make sure you got these notes down. See you soon.